In this video, we want to take a look at sums, differences, products, and quotients of functions. The definitions are actually very intuitive. So if I see f plus g of x, that means I'm going to figure out what f of x is, what g of x is, and then add those two things together. Likewise, you can guess that if it's f minus g, we'll take f of x minus g of x. We just have to kind of be careful with our signs on that one. The next one, if there's no sign in between, it's just fg, it means multiplication. So we'll take f of x times the g of x formula. And then the last one, f divided by g of x, means take f of x and divide it by g of x. On this one, we're going to have to be a little bit more concerned about the choices for x because it might not be defined if the denominator is 0. So we have to throw those x's out. We'll look at that in another video. So here is an example. I have f of x equals 3x squared plus 1 and g of x is equal to 4x minus 5. Well, if it says f plus g, then I'm simply going to take f of x, write it down, g of x, write it down, and put a plus sign in between. Okay, now you see I put parentheses there, or I'll put brackets there. That's just to kind of help me see that this is all of f of x, and I'm adding it to all of g of x. In this case, removing the parentheses doesn't change anything. We combine our like terms and get our final answer. Now the parentheses are really important because when I do a problem like f minus g of x, I've got all of f of x minus all of g of x. Those parentheses tell me I'm subtracting all of it. What that means is that I'm going to have to subtract the 4x and actually add a 5 because when you subtract a negative, you're adding. So my answer here is going to be similar to the f plus g, but slightly different for that constant term because of that sign change. If I have f g, that means multiply, and this is good old-fashioned FOIL in this problem. So distributing the 3x squared to both terms and then distributing the 1 to both terms. There are no like terms on this one, so we're done. The division problems are actually really easy because if it says f divided by g, we simply put f of x over g of x. Now this one's not going to allow me to use just any old x I want. I will have to restrict the domain, but again, we'll talk about that in another video. All right, let's look at specific cases. What if they want me to evaluate for a specific number? No matter what a help or a textbook will tell you, if you are just going to do f plus g of a number 6, you don't have to find that combined formula. I don't have to go back and say, oh, well, let me see what that rule is and then plug the answer into the rule. No, really, all you have to do is find what f of 6 is, find what g of 6 is, and then add those two things together. So here I've got f of x in this first bracket. Here's g of x in the second bracket. We're just plugging it into our formulas. We'll simplify the insides and remove the brackets and combine and get 128. If I want f minus g of a particular value, I'm going to take that number, in this case negative 1/2, and plug it into the first formula f of x. Then I'll plug it into the second formula g of x, and I will subtract the results. So order of operations tells me to clean up the insides first, and then remove those grouping symbols. So in this case, we're going to have a minus. Remember, that's going to change my sign, so that's why those brackets are really important. If I have fg of 0, so it's just f times g, I'm going to plug 0 into both of those formulas, multiply the results, and get my final answer. And again, same thing for division. If you have f divided by g of a number, find f of negative 3 on top, g of negative 3 on the bottom, and then simplify your answer. That's really all there is to combining functions. We will talk about domain in another video.